Our planet is a world of constant change. From the moment it formed over 4.5 billion years ago, Earth has never stood still. The continents drift on a sea of molten rock, journeying across the globe for billions of years. They are like giant rafts, carried by the slow but relentless currents deep beneath our feet. This is the story of that journey, of immense forces, creation and destruction. Continents have collided to form towering mountain ranges, then torn apart to create vast new oceans. Imagine watching Earth from space. Continents shift, collide, and break apart in a silent ballet. Over millions of years, the face of our planet transforms again and again, each movement shaping the world we know today. This movement, called plate tectonics, is the engine of our planet. Invisible to us, yet powerful enough to move continents and reshape the very surface of the Earth. It builds mountains, opens oceans, and shapes our world. Every valley, every mountain, every coastline is a chapter in this epic tale of movement and transformation. The story of the continents is the story of life, of resilience, adaptation, and change. As the land moves, life must adapt or perish, evolving alongside the ever-shifting Earth. Let's begin the journey and witness the incredible saga of our planet's restless continents. Our journey begins in the Hadean Aeon, an age named after the underworld of myth. 4.5 billion years ago, Earth was a glowing ball of molten rock under a toxic sky. The surface was a hellish landscape, constantly reshaped by volcanic eruptions and lava flows. Asteroids and comets bombarded the planet, keeping its surface molten. These celestial bodies brought with them vital elements, seeding the young Earth with the building blocks of life. Then, a Mars-sized object called Theia collided with Earth, forming the Moon and tilting our axis. This colossal impact not only gave us our satellite, but also set the stage for the seasons. As Earth cooled, heavy metals sank to form the core, while lighter rocks rose to create the crust. This differentiation laid the foundation for the planet's geological structure. Volcanoes erupted, releasing gases that built up a new atmosphere. This primordial atmosphere was rich in carbon dioxide, water vapor and other gases, creating a greenhouse effect that warmed the planet. Water vapor condensed and fell as rain, filling basins and forming the first oceans. These early bodies of water would become the cradle of life. From chaos and fire, the groundwork for our world was laid. The once fiery and tumultuous Earth began to stabilize, setting the stage for the incredible journey of life that was to come. In the beginning, Earth was a world of endless water. Its surface dominated by a vast, restless ocean. But then something remarkable happened. Out of this global sea, the very first land began to appear. Not the sprawling continents we know today, but tiny volcanic islands, their peaks steaming as they broke through the waves. These early islands were built from oceanic crust, which was thin and dense. This crust was unstable, constantly being pulled back into the mantle below, recycled by the planet's internal heat. Land, it seemed, was destined to be fleeting. But deep beneath the surface, a new process was underway. As oceanic crust melted and mixed with water, it gave rise to a new kind of rock, granite. Lighter and more buoyant than the basaltic crust, granite began to accumulate in patches, forming the first seeds of something greater. Unlike the dense oceanic crust, granite resisted being dragged back into the mantle. It floated, stubbornly refusing to sink, and became the foundation for the first persistent landmasses. Over millions of years, these volcanic islands and granite patches collided, driven by the slow churning of Earth's interior. Each collision welded together fragments of lighter crust, gradually building up larger and more stable land masses. These ancient, stable cores are known as Cratons. They are the oldest surviving pieces of Earth's crust. the unyielding foundations upon which today's continents rest. Some Cratons have endured for nearly 4 billion years, surviving the planet's most violent upheavals. They are time capsules, preserving clues to Earth's earliest history and the forces that shaped our world. For the first time, stable land resisted destruction. These Cratons drifted slowly across the planet's surface, carried by the movement of tectonic plates, marking the dawn of a new era. As these proto-continents grew, they created new environments, shallow coastal seas bathed in sunlight, where the first simple life forms likely found refuge and began to thrive. These sheltered waters became cradles of life, setting the stage for biological evolution. The growth of these landmasses was anything but peaceful. Violent collisions between islands and cratons built the first mountains, thickening the crust and reshaping the landscape in dramatic fashion. Each impact left scars that can still be traced in the rocks today. Over vast stretches of time, these landmasses continued to grow, merging into ever larger structures. The world's geography was in constant flux, with continents assembling and breaking apart in a slow, relentless dance. This was the beginning of the Great Continental Dance, a process that would shape the face of the planet for billions of years to come. At the heart of every continent, Cratons remained, ancient, unyielding and essential. They became the anchors around which new land gathered, the silent witnesses to Earth's unfolding story. With these stable cores in place, the stage was set for the next act. The coming together of land masses into supercontinents, vast assemblies that would dominate Earth's surface and drive the next chapters of geological history. The planet's surface, once a world of water and fleeting islands, was now ready for its next great transformation. A world where continents would collide, break apart and reshape life itself. The continents have never been still. Since the dawn of our planet, they have been on a restless journey, drifting, colliding and breaking apart in a grand, unending ballet. Deep beneath our feet, heat escapes from Earth's core, setting vast currents in the mantle into motion. These slow, powerful rivers of rock carry the continents above them inch by inch across the globe. This endless process is known as the Supercontinent Cycle, a repeating pattern where continents gather into giant land masses, only to be torn apart again over hundreds of millions of years. When continents converge, they trap immense heat beneath them. The land swells, bulging upward as pressure builds, until the supercontinent can no longer hold together. Eventually it cracks, splitting apart in a dramatic display of Earth's inner power. Magma surges upward through the fractures, rift valleys open, and the land is torn asunder. With each split, a new chapter of the cycle begins, setting the stage for continents to wander once more. This has happened not just once, but many times. Supercontinents like Pangea and Renewal have formed and vanished, each leaving its mark on the world. Columbia, too, was part of this ancient cycle, each supercontinent a chapter in Earth's ever-evolving story, each with its own unique landscapes and climates. When continents collide, the force crumples the land, thrusting up mighty mountain ranges that scrape the sky. When they split, rifts widen into new oceans, reshaping the face of the planet. The supercontinent cycle is not just a geological phenomenon, it shapes the oceans, sculpts the climate, and even steers the course of evolution itself. When continents cluster together, their interiors become vast, arid deserts, cut off from the life-giving moisture of the sea. Towering mountain ranges block the winds, redirecting rainfall and transforming entire regions into lush forests or barren wastelands. As continents break apart, species are isolated on drifting fragments of land. This separation sparks bursts of evolution, creating new forms of life and driving the incredible diversity we see today. The continents move in a slow, swirling dance, a dance that, though unseen, is the silent choreographer of life's unfolding drama. With every cycle, the planet's surface is reshaped, new landforms rise, and new creatures emerge to inhabit them. The rhythm of assembly and breakup is the heartbeat of Earth's geology, a pulse that has echoed for billions of years. The story of supercontinents is the story of change, of transformation, of endless renewal. And as one supercontinent faded, the next act began, ushering in the age of Rodinia and a new era in Earth's ever-changing saga. Imagine a world long before the age of dinosaurs, before forests, before even the simplest plants had taken root on land. Roughly 1.1 billion years ago, the Earth's continents, scattered and restless, began a slow, relentless journey toward one another. Over millions of years they collided and fused, forming a single colossal landmass, Rodinia, the first great supercontinent in our planet's history. Most of Earth's land was now gathered into this immense unified continent, surrounded by a vast global ocean. The world looked utterly alien compared to today. Rodinia's surface was stark and desolate. No trees, no animals, just barren rock and endless stretches of lifeless land. The only life clung to the oceans. Simple microscopic organisms drifting in the ancient seas, quietly shaping the chemistry of the planet. The birth of Rodinia was anything but peaceful. Ancient Cratons, massive, stable pieces of Earth's crust, smashed together in slow-motion collisions. These titanic forces crumpled the land, raising mountain ranges that rivaled the Himalayas, and leaving scars that geologists can still trace today. Modern geologists act as detectives, matching these ancient mountain belts, called orogenic belts, across continents that are now separated by oceans. Like pieces of a puzzle, these clues help us reconstruct the lost world of Rodinia. Deep within Rodinia's vast interior, far from the moderating influence of the sea, the climate was extreme. Scorching deserts stretched for thousands of miles, battered by fierce winds and wild temperature swings. But Rodinia's formation may have set the stage for one of the most dramatic events in Earth's history. Snowball Earth. As the supercontinent altered ocean currents and atmospheric patterns, the planet plunged into a deep freeze. Ice crept from the poles, eventually covering nearly the entire globe in a frozen shell. Beneath this icy world, heat from Earth's interior built up, trapped under the massive weight of Rodinia. Over millions of years, this pressure became too great, and cracks began to split the supercontinent apart. Volcanoes erupted along these rifts, pouring lava and gases into the atmosphere. As Rodinia broke apart, new oceans formed, reshaping the face of the planet once again. The breakup of Rodinia created vast new shallow seas, environments rich in nutrients and sunlight. These waters became cradles for the evolution of more complex life, setting the stage for the next leap in Earth's story. As the climate warmed and the ice retreated, life exploded in diversity. New forms appeared, filling the oceans with a dazzling array of creatures. Throughout Earth's history, supercontinents have come and gone, each one leaving a profound mark on the planet's climate, oceans, and the evolution of life itself. After Rodinia's dramatic end, the stage was set for the rise of an even more legendary supercontinent, one whose name echoes through textbooks and imaginations alike, Pangea. After the ancient supercontinent Rodinia broke apart, the scattered land masses began a slow, relentless journey across the globe. Over millions of years, these drifting continents gradually moved closer together, until, about 335 million years ago, they collided and fused to form a new supercontinent, Pangea. Pangea was a colossal landmass, stretching from the frozen reaches of the North Pole all the way to the icy south. It was surrounded by the vast, endless waters of the Panthalassa Ocean, a single, immense sea that encircled the supercontinent like a blue ring. The sheer size of Pangea created a world of climate extremes. Along its sprawling coastlines, powerful monsoon rains drenched the land, nurturing lush forests and swamps. But deep in the interior, far from the ocean's influence, the land was parched and lifeless. A vast desert where little could survive. Only the hardiest plants and animals could endure these harsh conditions. In the arid heart of Pangea, tough, drought-resistant plants clung to life, while resilient reptiles and amphibians adapted to the relentless heat and dryness. As the continents merged, countless shallow seas vanished, their waters squeezed out by the rising land. These disappearing habitats spelled disaster for many marine species, leading to a dramatic loss of biodiversity in the oceans. On land, however, the formation of Pangea opened up new possibilities. For the first time, animals could migrate freely from one end of the world to the other, leaving behind a trail of fossils that would one day be discovered on continents now separated by vast oceans. Fossils of creatures like Lystrosaurus, a sturdy beaked reptile, have been found in rocks on continents as distant as Africa, Antarctica and Asia. These discoveries are powerful evidence that these lands were once joined together. In the early 20th century, a German scientist named Alfred Wegener noticed these remarkable similarities. He pieced together the puzzle of matching fossils and rock formations, daring to propose the revolutionary idea that continents drifted across the Earth's surface. The existence of Pangea changed the course of evolution. Plants and animals spread across the supercontinent, adapting to new environments and giving rise to new species. The world was a place of both opportunity and peril, shaping the destiny of life on Earth. But nothing on Earth is permanent. Over time, immense forces within the planet began to tear Pangea apart. Cracks appeared and the supercontinent slowly started to break into pieces. These fragments would drift away, eventually forming the continents we know today. The birth of the modern world was underway, a process that would take millions of years and reshape the face of the planet. The world was about to change forever, setting the stage for the next dramatic chapter in Earth's story. Pangea, like the ancient supercontinent Rodinia before it, was both a marvel of unity and a ticking clock of inevitable change. Its vast expanse stretched across the globe, a single landmass surrounded by a mighty ocean, but deep within forces were building that would soon tear it apart. Over millions of years, heat trapped beneath Pangea's thick crust began to build, stretching and fracturing the land above. Around 200 million years ago, these immense pressures finally overcame the strength of the supercontinent, and Pangea began to break apart, its fate sealed by the restless energy within the Earth. A great rift valley opened, splitting the land and allowing molten magma to surge upward. This rift widened over time, eventually giving birth to the Atlantic Ocean, as new seafloor formed and continents slowly drifted away from each other. North America began its long journey away from Africa and Europe, while Pangea itself split into two massive fragments, Laurasia in the north and Gondwana in the south. These new continents would become the building blocks of the world we know. Between these drifting giants, the Tethys Sea emerged, a vast blue expanse that would shape the climate and ecosystems of the age of dinosaurs, separating the northern and southern continents and nurturing new forms of life. Gondwana itself was not immune to change. It began to splinter further, with South America and Africa slowly drifting apart, their separation creating the South Atlantic Ocean and setting the stage for the continent's unique evolutionary paths. India, once nestled against Antarctica, broke free and raced northward at a remarkable pace, while Australia too began its solitary voyage, drifting across the southern seas toward its present position. Over tens of millions of years, these wandering continents gradually moved into positions that are more familiar to us today, their shapes and locations slowly morphing into the outlines we recognize on modern maps. Beneath the oceans, mid-ocean ridges continued to push the continents apart, driving the relentless process of seafloor spreading. New oceans formed, and the face of the planet was transformed again and again. The breakup of Pangea was a turning point in Earth's history, giving rise to the Atlantic, Indian and Southern Oceans. These vast waters would become the highways of life and climate, shaping the destiny of continents and creatures alike. As the continents settled into their new homes, the world was forever changed. The extinction of the dinosaurs opened the door for mammals to rise, filling the empty niches and beginning their own evolutionary journey. Slowly the world map took on the shapes we know today, moulded by the invisible hands of time and geology, each continent a testament to the planet's restless spirit. Yet the continents never truly rest. They continue their slow, ceaseless journey across the globe, driven by forces deep within the Earth. The story of Earth's surface is far from over. Even now the continents shift and change, hinting at new chapters yet to be written in the epic tale of our ever-evolving planet. The movement of continents has profoundly shaped Earth's climate and life over millions of years. When land clusters at the poles, vast ice sheets form, reflecting sunlight and cooling the planet significantly. The opening and closing of seaways, such as the formation of the Antarctic circumpolar current, can isolate continents, altering ocean currents and global temperatures. Continental drift acts as a planetary thermostat, driving cycles of warming and cooling that have profound impacts on the environment. As continents break apart, species become isolated, leading to unique evolutionary paths, explaining the distinct wildlife of Australia, like kangaroos and koalas. When continents collide, species from different regions meet, compete and adapt, leading to new evolutionary developments. The greatest mountain ranges, like the Himalayas, are born from these monumental collisions, towering above the landscape as a testament to the power of tectonic forces. The Himalayas began forming around 50 million years ago when the Indian plate crashed into Eurasia, and they continue to rise even today. Most volcanoes are found at plate boundaries where tectonic plates pull apart or one slides beneath another, creating a fiery spectacle. Volcanic eruptions can have a cooling effect on the planet by blocking sunlight with their ash and gas, leading to temporary climate changes. The restless movement of continents drives the evolution of life, the shifting of climates, and the very shape of our world. Mountains, oceans, and life itself are all products of this grand geological dance, constantly evolving and reshaping the Earth. The story of our planet continues, with the shifting continents shaping the world we know and the life that inhabits it. The world map we know today is not a static image, but the latest chapter in a 4.5 billion year epic. Each continent, each ocean, every mountain range and valley, these are the living records of a planet in perpetual motion. Over eons, continents have collided and split apart, mountains have risen and crumbled, and oceans have opened and closed. This relentless dance of land and sea has shaped the face of our planet, sculpting the landscapes we call home. Look closely at the coastlines of Africa and South America. Like pieces of a giant puzzle, they still fit together, a silent testament to a time when they were joined as one, part of the ancient supercontinent Gondwana. The Appalachian Mountains in North America share their roots with the Scottish Highlands and the mountains of Scandinavia. Once these ranges were a single chain, only to be torn apart by the birth of the Atlantic Ocean, their rocky bones now separated by thousands of miles of water. But the story is far from over. Even now, continents drift at the pace of growing fingernails, imperceptible in a human lifetime, yet unstoppable over the ages. The Atlantic Ocean continues to widen, while the Pacific slowly shrinks. New ocean basins are born as tectonic plates pull apart, and old ones vanish as plates dive beneath each other, recycling the very crust of the Earth. In East Africa, a great rift is tearing the continent apart. Someday, perhaps millions of years from now, the land will split completely and a new ocean will flood in, giving birth to a new continent and forever altering the map. Scientists, peering far into the future, predict that the continents will not remain scattered forever. In about 250 million years, they may once again converge, merging into a new supercontinent, Pangea Ultima. The cycle of assembly and breakup will continue as it has for billions of years. All of this is powered by the heat deep within our planet. The churning molten core drives the movement of tectonic plates, fueling the endless transformation of Earth's surface. Our world is not fixed but dynamic, ever-changing. What we see today is just a single frame in a movie that began long before us and will continue long after we are gone. By studying the rocks beneath our feet, geologists unlock the secrets of this journey. Each layer tells a story of ancient seas, vanished mountains, and continents on the move. Understanding this epic saga deepens our appreciation for the powerful forces that have shaped and continue to shape our home. The story of the continents is, in many ways, our own story, written in stone and measured in the vastness of time. The restless Earth will keep moving, shaping the future as it has the past. And as we look to the horizon, we are reminded that our planet's journey is far from finished, its legacy still unfolding beneath our feet. Imagine for a moment travelling millions of years into the future. The continents beneath our feet are not anchored, but set adrift on slow-moving currents of molten rock. What will Earth look like when the next supercontinent forms? Scientists have pieced together clues from the rocks, the ocean floors, and even the magnetic memory written in ancient stones. Their predictions paint a mesmerizing picture of what lies ahead. As the Atlantic Ocean continues to widen, the Americas drift farther from Europe and Africa. The Pacific, meanwhile, is shrinking, its vast expanse destined to vanish as new mountain ranges rise where tectonic plates collide. Perhaps, in the distant future, Asia and the Americas will fuse, forming towering peaks where the Pacific once was, and a new immense landmass, Pangea Ultima, will dominate the globe. But the story doesn't end with shifting land. As continents move, they reshape the climate, redirect ocean currents, and trigger waves of evolution and extinction. Ice ages may come and go, deserts may bloom into forests, and new species will emerge to explore the ever-changing landscapes. Humanity, if still present, will witness coastlines redrawn and mountains forged anew. Our cities may become fossils, buried beneath layers of future Earth, silent witnesses to a world forever in motion. Earth's restless continents remind us that change is the only constant. From the fiery birth of the planet to the formation of supercontinents yet to come, our world is a living, breathing entity. The story of drifting continents is not just ancient history. It is the promise of a future yet unwritten, a reminder that the ground beneath us is alive with possibility. As we gaze at the world map today, let us remember we are travellers on a journey that began eons ago and will continue for ages yet to come. The adventure of our planet is far from over, and its next chapter is waiting to unfold. Throughout this epic tale of drifting continents and reshaped worlds, one element remains constant: our deep connection to the planet beneath our feet. For thousands of years, humans have built civilizations on the shifting crust, drawing invisible lines on maps and calling them home. Yet, as we've seen, these boundaries are only temporary. written on a surface that is always in flux. Imagine ancient peoples gazing at the horizon, unaware that the mountains they revered were once ocean floors, or that the fertile valleys they farmed were forged by continents colliding. Our myths and legends often speak of lands lost and found, of great floods and sudden upheavals, echoes of Earth's restless spirit woven into our collective memory. Today, satellites trace the subtle drift of continents, and scientists decode the secrets of rocks that predate humanity itself. We now understand that earthquakes, volcanoes, and the rise and fall of seas are not just random events, but chapters in a grand planetary narrative. This knowledge reshapes how we plan our cities, protect our coastlines, and imagine our future. But more than that, it invites us to reflect on our place in the story. We are not separate from Earth's journey. We are part of it. Our innovations, our art, our struggles and triumphs become layers in the ongoing history of this living planet. As the continents continue their slow dance, we are faced with a profound choice: to live in harmony with Earth's rhythms, or to ignore the lessons written in stone. So, as you look at the world around you, the mountains, the rivers, the land beneath your feet, remember, you are standing on a planet that has never stopped changing. And in this ever-shifting world, our stories, too, are always unfolding. The adventure continues, and we are all part of the next chapter. As we look forward, it's worth pausing to listen to the echoes of Earth's deep past, a past written in stone, in fossils, and in the very fabric of the continents. Each layer of rock beneath our feet is a time capsule, preserving the trials and triumphs of life across billions of years. Consider the story of the Permian extinction, when nearly all life was wiped out as continents converged and climates shifted. Or the rise of flowering plants spreading across the world as the continents drifted apart, transforming barren landscapes into vibrant ecosystems. These ancient events remind us that change is not always gentle, and survival often depends on adaptation, resilience, and the ability to read the signs written in nature's language. Today, we face our own turning points: climate change, rising seas, and the reshaping of landscapes by human hands. But we are not the first to confront a world in flux. By studying the patterns of the past, we gain insight into the challenges ahead. The rocks tell us how life endured through mass extinctions, how continents healed and reformed, and how time and again new beginnings rose from the ashes of catastrophe. As we chart our future, let us remember the Earth is both a witness and a teacher. Its ancient lessons urge us to respect the delicate balance of our environment, to adapt with wisdom, and to leave a legacy that future generations can build upon. In the grand sweep of geological time, our moment is brief, but our choices now can echo for millennia. The story of Earth is still being written, and with each step we add our own chapter to this timeless epic. As our journey through Earth's ancient saga draws to a close, we find ourselves standing at a crossroads, a point where knowledge and responsibility meet. The continents beneath our feet have drifted, collided and transformed, shaping the landscapes we call home. But now, for the first time in history, it is not just the forces of nature but human hands that hold the power to shape the planet's next chapter. Imagine a distant future. A child, centuries from now, unearths a layer of rock that tells the story of our age. What will those stones reveal? Will they speak of flourishing forests and clean rivers, of thriving wildlife and balanced climates? Or will they bear witness to lost species, vanished glaciers, and scars left by reckless ambition? The answer depends on the choices we make today. Around the world, communities are rising to the challenge, restoring forests, protecting endangered species, and seeking new ways to live in harmony with the land. Scientists decode the secrets of ancient rocks to warn us of tipping points. while innovators develop technologies that harness the Earth's energy without exhausting its gifts. Each of us is a guardian of this legacy, entrusted with a story that began long before us and will continue long after we are gone. By honouring the lessons carved into stone and soil, we can become wise stewards of a living planet, one that sustains, inspires and endures. Let us remember, the continents will continue to drift and mountains will rise and fall, but the mark we leave is ours to choose. May we write our chapter with care, courage and hope, so that when future generations look back, they will see not just the challenges we faced, but the wisdom and resolve with which we answered them. Imagine far in the future a group of explorers uncovering a time capsule buried deep beneath the roots of an ancient forest. Inside, they discover artifacts from our era, a handwritten letter, a solar-powered device, a tiny vial of clean water, and a photograph of children planting trees beneath a blue sky. These relics, humble yet profound, become the clues to unravelling the story of our age, a chapter marked not only by struggle, but by hope and transformation. As the explorers study these treasures, they piece together the choices we made when the fate of our world hung in the balance. They read of cities that reimagined themselves as green sanctuaries, of rivers once polluted now running clear, of animals brought back from the edge of extinction. They learn how communities joined hands across continents, bridging cultures and generations to heal the wounds of the past and build a more resilient future. The explorers marvel at the resilience woven into our story, the way humanity learned to listen to the earth, drawing wisdom from its ancient cycles and adapting to its ever-changing rhythms. They see in our actions a message that transcends time, that every generation shapes the legacy it leaves behind, and that even the smallest act of stewardship can echo across millennia. In their eyes, our age is not simply a cautionary tale, but a testament to the enduring spirit of those who chose to protect and cherish the planet they called home. As they carefully return the artifacts to the Earth, the explorers carry forward the lessons of our chapter, reminding themselves and all who come after that the story of Earth is still being written one choice at a time. The continents will continue to drift and the mountains will rise and fall, but the message we leave, etched in stone, soil and memory, will guide those who follow. Let us hope it is a message of hope, unity and respect for the world that sustains us all. Beneath the restless surface of the world's oceans lies a record older than any written language. Here, in the silent darkness, layers of sediment have settled for billions of years, each grain a memory of Earth's shifting past. Imagine a submersible, its lights piercing the inky black, descending to the ocean floor where ancient rocks and fossils tell stories no eye has seen. As the explorers glide above the abyssal plains, they discover stromatolites, living fossils that once breathed oxygen into a young, hostile world. These structures, built by colonies of bacteria, became the architects of our breathable atmosphere, shaping the very possibility of life on land. The explorers collect core samples, revealing bands of iron and clay, evidence of ice ages, volcanic eruptions, and the slow wandering of continents. In the quiet, they listen to the echoes of submarine volcanoes, their eruptions forging new islands in darkness. They witness hydrothermal vents, teeming with life in places untouched by sunlight, reminding us that resilience and adaptation flourish even in the harshest environments. Each discovery is a testament to the ocean's role as both cradle and archive of life. Its tides shaping coastlines, its currents weaving a global tapestry that connects every continent. The explorers realize that the ocean is not just a backdrop to Earth's story, but a living participant, its depths holding the secrets of mass extinctions and rebirths, migrations and convergences. They see how the ocean's chemistry changes with every human action, how plastic and warming waters leave a signature that future generations will read in the shells of ancient creatures. As the submersible ascends, the explorers carry with them a profound respect for the ocean's memory. Above, the waves glitter under the sun, a reminder that while land may bear the stories of our civilizations, the sea holds the whispers of all that came before. In honouring the deep, we honour the full sweep of Earth's history, past, present and the unwritten future. Let us remember the story of Earth is not just etched in stone, but written in water, ever-flowing, ever-renewing, a legacy for those who listen to the whispers from the deep. High above the ocean's shimmering surface, another archive drifts silently across the globe, the sky. Here, in the endless blue, clouds form and dissolve, winds race and circle, and the atmosphere itself becomes a living record of Earth's evolving story. Imagine the camera soaring upward, leaving behind the hush of the deep, rising into swirling mists where sunlight paints fleeting masterpieces on the canvas of air. Each cloud is a messenger, born from the heat of ancient sunlight, carrying moisture gathered from distant seas and shaped by the invisible hand of planetary winds. These winds, sculpted by the rotation of the earth and the warmth of the sun, have for eons carried dust, seeds and life across continents. In the high atmosphere, particles from volcanic eruptions and meteor impacts have painted sunsets red and cooled the planet, leaving traces in polar ice and ancient rings of trees. The camera follows the journey of a single water droplet, evaporated from the Pacific, swept by the jet stream across mountains and plains, finally falling as rain on a distant forest. This cycle, timeless and unbroken, has carved valleys, nurtured ecosystems and shaped civilizations. It has seen the rise and fall of empires, the migration of animals, and the birth of life itself, but the sky too bears the marks of our presence. Greenhouse gases thicken the air, altering weather patterns and stirring the delicate balance that has allowed life to flourish. Satellites now orbit above, their sensors watching the swirling storms and shifting jet streams, capturing data in a new kind of memory, a digital echo of the sky's ancient wisdom. As twilight deepens, the clouds glow with the last light of day, a reminder that the sky is not merely an empty void, but a dynamic storyteller. It holds the memory of mass extinctions, of ice ages and warm periods, of the first breaths of oxygen and the silent flutter of wings. The atmosphere connects every living thing in an endless dance, a breath shared across time and space. In the quiet after the storm, as the stars emerge, we remember. The sky's memory is written in every gust of wind and every drop of rain. To understand Earth's story, we must look not only to the stone and the sea, but also to the ever-changing sky, our planet's most ephemeral yet most enduring witness. Beneath our feet lies a hidden world, a realm of darkness and mystery where the Earth's deepest secrets are written in stone. Imagine the camera diving into the ground, passing through layers of soil, rock and ancient sediments descending into the heart of the planet. Here in the subterranean depths, the story of Earth unfolds in a language of pressure and heat, where time moves at a different pace. This is the domain of tectonic plates, colossal slabs of rock that drift atop the semi-fluid mantle. Their slow, relentless movement shapes our world, creating mountains, forming oceans and triggering earthquakes. Picture the camera tracing the boundary between two plates, where molten rock from the mantle rises to the surface, creating new crust at mid-ocean ridges. In the darkness, hydrothermal vents spew mineral-rich water, nurturing unique ecosystems that thrive in the absence of sunlight. Deeper still, the camera reveals the mantle, a vast region of solid rock that flows like a slow, viscous liquid. Here, convection currents churn, driven by the heat from the Earth's core, moving the plates above. The mantle's movement is a testament to the planet's dynamic nature. a reminder that even the solid ground beneath us is in constant motion. At the core of the Earth lies a sphere of molten iron and nickel, generating the magnetic field that shields our planet from solar radiation. This core, a hidden dynamo, is essential for life as we know it. The camera zooms in on the swirling currents within, capturing the raw energy that powers the magnetic field, a force that has flipped and shifted throughout Earth's history. But the subterranean world holds more than just geological marvels. It is a repository of ancient life where fossils of long-extinct creatures lie preserved in the rock. The camera pans over a fossilized forest buried millions of years ago by volcanic ash, now a silent witness to a bygone era. These fossils tell the story of evolution of life adapting and thriving in a changing world. Yet the underground is also a place of human exploration and endeavour. Mines burrow deep into the earth, extracting precious minerals and metals that fuel our civilization. The camera follows a miner's lamp as it illuminates veins of gold and silver resources that have driven human history and shaped economies. As the camera ascends back to the surface, we are reminded that the ground we walk on is but a thin veneer over a vast and mysterious world. The Earth's subterranean secrets are a testament to the planet's complexity and resilience, a reminder that to truly understand our world, we must look beneath the surface, to the hidden forces that shape our lives in ways we are only beginning to comprehend. In the cool, silent depths, the Earth's past, present and future are etched in stone. It is a story of fire and ice, of creation and destruction, a testament to the relentless forces that have shaped our world. As we stand on the surface, let us remember the hidden world beneath our feet, a world that holds the key to understanding the planet we call home. Beneath the calm surface of our world, Earth pulses with energy, a restless force that occasionally bursts forth in moments of dramatic upheaval. In this hidden theatre, immense pressures build and release, shaping the landscape in sudden, unforgettable events. Imagine the camera following a slow-motion ripple deep within the crust, where tectonic plates grind and strain against one another. In a flash, the tension snaps, an earthquake unfurls. The ground trembles, ancient rocks fracture, and the very earth seems to breathe. These seismic waves race outward, shaking cities and mountains alike, reminding us that our planet is alive, its heart beating with power and unpredictability. But not all of Earth's energy is released in silence and shadow. Sometimes the ground opens and fire meets sky. The camera soars to the mouth of a volcano where molten rock surges from the mantle, bursting forth in a fountain of lava and ash. Volcanic eruptions are both destructive and creative, obliterating everything in their path, yet also forging new land, enriching soils, and even altering the global climate. In these moments, we witness the Earth's power to destroy and to renew. Travel now to the Ring of Fire, a vast circle of volcanic and seismic activity encircling the Pacific Ocean. Here, the forces beneath the crust are in constant motion, building islands, shaping continents, and driving evolution. The camera dives beneath the waves to reveal underwater volcanoes, hidden architects of the ocean floor, silently crafting new worlds in the darkness. Yet these dramatic events are more than mere disasters. They are vital to the planet's cycle of renewal. Volcanic ash fertilizes forests, earthquakes create new habitats, and geothermal energy offers us a glimpse of the power locked within our world. Even in the aftermath, life finds a way. Plants sprout from cooling lava, animals return to reshaped valleys, and humans rebuild, learning and adapting with each upheaval. As the camera pans over a landscape scarred and transformed by these forces, we are reminded that Earth's story is one of perpetual change. The planet's pulse, measured in quakes and eruptions, drives the evolution of life and the formation of new worlds. It is a force that demands respect, awe, and understanding. In the end, the pulse of the planet is both a warning and a promise, that from destruction comes creation, and from chaos, new beginnings. The forces of renewal beneath our feet are a testament to Earth's resilience, a reminder that in the dance of fire and stone, life always finds a way forward. Beneath the tumult of earthquakes and the fiery breath of volcanoes, another, quieter story unfolds, a story written in the hidden language of minerals and gems. Deep within Earth's crust, unimaginable heat and pressure transform simple elements into crystalline masterpieces. These silent architects, forged over millions, even billions of years, carry the secrets of our planet's history in their atomic patterns and vibrant colours. Imagine the camera journeying down through layers of rock, tracing the slow birth of a diamond, a journey that begins as carbon atoms locked deep in the mantle are pressed together with unimaginable force. Over eons, they form a crystal lattice rising toward the surface in volcanic eruptions, finally to be discovered by human hands. Each gem, from luminous emeralds to fiery rubies, is a time capsule, a fragment of Earth's memory, shaped by the restless energy below. But minerals do more than dazzle. They build the very foundations of our world. Quartz, feldspar, mica, these unassuming minerals make up the rocks beneath our feet, the mountains on the horizon, and the sands that drift across deserts. The camera sweeps across a sparkling granite outcrop, zooming in to reveal the intricate mosaic of crystals, each with a unique story of formation and transformation. Some minerals capture moments of cataclysm, tiny bubbles of ancient atmosphere trapped in amber, or bands of colour marking the passage of seasons in a stalactite's slow growth. Others, like the rare blue lapis lazuli, have travelled continents, traded and treasured by civilizations for millennia, shaping art, culture, and even the course of history. These silent witnesses are far more than geological curiosities. They are the storytellers of Earth's deep time, revealing the forces that built mountains, split continents, and fueled the rise of life itself. Through their study, scientists unlock the mysteries of plate tectonics, climate shifts, and the origins of water and atmosphere. As the camera lingers on, a geode cracked open to reveal a galaxy of crystals glimmering within, we are reminded, beneath every quake and eruption, beneath every mountain and plain, the mineral world is at work, weaving the fabric of our planet. In every stone, a story waits to be told, a story of transformation, resilience, and the silent artistry that shapes the earth. In the end, these treasures beneath our feet connect us to the deep past and the ongoing saga of a restless creative world. The next time you hold a pebble or marvel at a sparkling gem, remember, you are holding a fragment of Earth's eternal story, written in stone, waiting to be read.